everyone, welcome to an algebra tutorial video learning about how we can use graphs to approximate and solve exponential functions. So here's our problem. Given that we have a function f of x and it's equal to 48 times 1.05 to the x power, so we're starting with 48, we're multiplying it by 1.5 over and over and over again. For what x value does our function give an output value of 122? Well, this is function notation stuff here, so let me rewrite it another way just to help interpret it. Another way of saying this is, when does 48 times 1.05 to the x power, when does that equal 122? In other words, can we solve for x? Another way to think about it is I'm given a y value. I know that y is equal to 122. So what is x? So here's some different ways to kind of think about the problem. Think about it in function notation, solving an equation or a point on a graph. And we're going to use all three to kind of help understand it. And actually the method for solving this to isolate x to get what x equals, we can easily do that with a linear equation, but with exponential functions it's actually kind of tricky. We won't learn about it until later on when you get into logarithms and more. It's more of an algebra 2 type topic. But for now, we can still understand what it is we're trying to find, and we can get pretty darn close by using a graph. So I'm going to go ahead and pull up a graph of this function, and then we'll talk about what we see on the graph and how to use that to help solve this equation out. All right, there's my graph. So let's think about what we have going on here. We got my exponential curve. That's really easy to see. And it looks like if I want to interpret some things, there's my y-intercept. And it should be when x is 0, my y value is 48. I can get that straight from my function because I'm starting at 48. But let's think of what we want to find. We want to know what x value, let me switch to a different color here. We want to know what x value gives me an output value of 122. Or I know that y is 122 and I want to find the x value that goes with it. So I'm going to find the y-axis, it's the vertical one right here. And I'm going to find 122. Look at the way it's scaled. Each block is a unit of 10. So 122, there would be 120. 122 would be just a little bit above that, which will be right at this point on the function there. Well, now I can really easily see, okay, so my x value, where does that line up? It lines up just a smidge to the left of this line right about there, which if I had to approximate, it looks like each x block is broken up into a unit of 10. So that would be 0, 10, just under 20. So if I had to do an approximation, I would say this point right here, to get a y value of 122, which we just approximated from the graph, I would approximate a x value of about 19. And that's a reasonable expectation just by eyeballing it from a hand graph, and we can get there. I think in reality the value is more closer to 19.1 or 19.2, but again, we're really close. We know it's about 19. Let's go ahead and check just to see how close they are. Let's put 19 into our function and see what we get back. So I'm going to do 48 times 1.05 to the 19th power. I'm going to see how close we actually are to 122. So 48 times 1.05, 48 times 1.05 to the 19th power, and I get 121.294. So we're a little bit less. It's not an exact value, but it's a reasonable approximation. And it again, depending on what our scenario is, depending on what we want to find, it may be good enough just to say, yeah, about 19. But there you go, we can read all sorts of values on the just from the graph and use the fact that the graph represents all the possible points to help us think about solving for functions and finding solutions to exponential functions.